All right, what's happening, guys? Let's do this Unit 4 test review. Let's get this thing out of the way. So first of all, quadrilateral classification word bank, something you guys should be aware of. This is a quadrilateral will never have, like it's nothing special, will not have any markings. So there's going to be no markings at all if you have a just a regular quadrilateral. All of these ones here, technically, all of them are parallelograms. So the big deal for the fact that they're all parallelograms is you have to do something special with it. So a parallelogram just means two pairs of parallel sides. A rhombus is going to be all four sides same length. A rectangle, four angles the same. And really, they're four angles that are right angles. And a square is both a rhombus and a rectangle. So this is going to be four sides and four angles. Four sides and four angles. The same. Same. After that, a kite. A kite in this one will end up looking like a kite, but the main thing to deal with a kite here is the fact that you have two pairs of adjacent congruent sides. So, question number 4. They have these two are the same. These two are the same. They're next door to each other. Two pairs that are the same there. These last two trapezoids, both of these have only one pair of parallel sides. And isosceles, just like a triangle, isosceles trapezoids have one pair of same length. Sides of same length. Okay. Anyways, here we go. This one, we have parallel sides, but not any other markings. This is going to be a regular old trapezoid. This one over here, we have all four right angles, but not going to be the same. So all four right angles is a rectangle. And then on number 3, we have two pairs of parallel sides and no other special markings. So it's going to be a parallelogram. Parallelogram. I mean, the word's over there on the side, right? I should be able to spell it. All right. After that, this one I was just talking about earlier is a kite. Question number 5. That's going to be a square. It's got all those sides the same and all the angles the same. And if it's got just the sides the same, it's a rhombus. Beautiful. Moving on to question number 7. Find the measure indicated. So we have all four of these sides being the same length. So we call that guy a rhombus. Rhombuses have a rule just like all parallelograms that they divide their diagonals equally. So you're told that WQ is 16, but the diagonals are divided up equally. So that means this is also 16, and 16 plus 16 is in fact 32. Cool. Question number 18 now. On question number 18, it asks you to find QS. So QS is this length here, and that's what you're trying to figure out. You're told that PR, this length over there, is 18, but it's an isosceles trapezoid. Isosceles trapezoids have equal diagonals, and therefore this one's also 18. So it's like kind of really just a freebie copy. If you're watching this video early, I have not taught this exact topic in class because it was not on the quadrilaterals packet. I guess I just forgot to leave it on there, but I'm going to kind of blow this picture up, or at least a part of it. So I'm going to make it a little bit larger there. And the idea is you're told that this length is 5, and then you're told the hypotenuse, because this is 13, this is also 13. So you have an a squared plus b squared equals c squared situation. You can simply say that x squared plus 5 squared is equal to 13 squared, because we have, this is like our a, our b, our c, and a squared plus b squared equals c squared, and we're just solving from there. So we have x squared plus 25 is equal to 169. Subtract 25 on both sides to get 144, and then take the square roots of both sides, and you will end up with 12. And there we go is our final answer. Please be aware, I actually recommend personally skipping the whole idea of the quote unquote correctly set up equation and remembering instead there are some special triangles. The special triangles we're talking about are 3, 4, 5. That's one of the answers. A 5, 12, 13. Another answer, that's the one we're just in. So we have a 5 and then a 12 and then a 13. And the other Pythagorean triples, I recommend memorizing 7, 24, 25. We have 8, 15, 17, and 9, 40, 41. I already talked about those earlier in the year, but if you wanted to have those jotted down for yourself to make life really fast on the test, you definitely can. Don't forget, you also multiply those by 2, multiply them by 3. I think one of them has that multiplied by 2 on there. Anyways, let's move on to question number 10. So on question number 10, the measure of UVT is going to be, this is the fact that this is an isosceles triangle, and that's what's created whenever we have a rhombus. So in other words, these two are exactly the same. They're going to be both, I'm going to call them the letter X. And because they're exactly the same, we're simply going to be doing 180 minus 100 divided by 2, and that's going to give us 50, right? Nope, 40. I can do math. Oh my gosh, Mr. Richards. Almost messed that one up. By the way, if you want to do an equation for this one instead, it would have been x plus 100 is equal to 180, or 2x equals 80, or x equals 40. There's another way of doing it if you want to check it out that way. On number 11, you could do it a couple different ways. You could say, hey, all four of those, add up to 360. You could remember in a trapezoid that the two angles next door to each other are going to add up to 180 as long as they're on different parallel lines. I think that's going to be the easiest way to do this one. 180 minus 65, that's going to be a total of 115 degrees. Nice. All right. And question number 12, you're told to find the measure of angle U in a kite. The idea is that these opposite sides do in fact have that same exact length or same exact value on opposite sides as long as they're in between the sides that are of different lengths. So finally we can do 360 minus the 102 minus another 102 minus 64. I'm getting lazy and using my calculator first time on this pack anyways. You can see I used it quite a bit in that last one. That's going to give us 92. Put a degree symbol on there if we want to. Nice. Moving on to that next page, we have question number 13. So find the measurements in each parallelogram. One of the big ideas on a parallelogram is that the opposite angles are equal to each other. So we're going to have 8x plus 4 is equal to 9x minus 2. And I'm going to do this one moving the x's to the right instead of the left because I get 9x minus 8x, which is simply x. And on the other side there, we're going to get 2 plus 4, which is 6. And finally, for the measure of angle P, that's going to be equal to 8 times 6 plus 4. What's that going to be? 48 plus 4 is 52. Beautiful. All done. By the way, you can check your work if you want to by plugging into the other one. 9 times 6 minus 2 is also 52, so that gives you the right answer as well. On this one, just like before, the next door neighbors in a parallelogram always add to 180, so 35x plus 25x equals 180, or in other words, 60x equals 180, or x equals 30, and therefore the measure of angle W is going to be 25 times 30, and 25 times 30 is, times 3. Oh my gosh, Mr. Richards. Oh boy. Too many errors, guys. Too many errors. I apologize. This is the second error in my videos today. Maybe the third. I don't even know. There's 75 degrees. Let's move on to all the area formulas. So on the non-honors test, all the formulas are given to you. On the honors test, you got to actually remember them. That's going to be one of the big challenges for that honors test. But area of a parallelogram is the base times height. So in this case, I'm just doing 4 times 5, and that's going to give me a nice value of 20. I am requiring those units 20 centimeters squared. So again, honors only to require the units. On the non-honors, you can just put the number. That's fine. Number 16 here is definitely just a square. So 8 squared is going to be 64. 4. Don't forget your centimeters squared. On this one, we have a nice little rectangle. 7 times 4 is going to give us 28 inches squared. When it comes to a triangle, your triangle there is going to be 1/2 times the base times the height. 8 times 3 is 24. 23 divided by 2 is 12. 12 inches squared. Trapezoid formula is base 1 plus base 2 divided by 2 multiplied by the height. And this guy right here is going to be exactly 7 centimeters squared. I recommend the calculator on that one for sure. And on number 20, we have diagonal times diagonal, divide by 2. 8 times 4, divide by 2. It's going to give you a 16. Don't forget your feet squared on there. Here we go. We're moving on to the back page here. The back page is the same exact idea, except it's backwards. So you're told that the area is already this 88. And I'm going to go ahead and use the letter X instead of a question mark there. So here we go. And that's going to be equal to 11 times X base times height. Divide both sides by 11. And you get 8. And again, don't forget your units. This one's not squared, just centimeters. And on this one, we're going to have our area, our 15.5 is equal to 1/2 times the base times the height that is perpendicular to the base. Again, I'm calling that X. In order to solve this one, I do recommend a couple different ways. You can do 1/2 times 6.2 and then divide, or I think the better way to do this one is to say X is equal to, we're going to move the 2 to the top. So that 2 came to the top, and the 6.2 gets divided. Regardless, if you do it right, you get exactly 5 for your centimeters. Oh my gosh, I can't even read that. Read, Mr. Richards. All right, 5 centimeters. Here we go. And on this one, again, this is another one that if you are watching this a little bit earlier, I might not have taught this in class yet because I forgot to put it on that quadrilaterals packet. But this is called that mid-segment of a trapezoid. This is actually what we're using to figure out that area formula. It's the base 1 plus the base 2 divided by 2. So we have the 10 plus the 16 divided by 2. It's the average of those two numbers. So 10 plus 16 is 26 divided by 2 is 13. We're all done, guys. Peace out. Have a great rest of your day.